So glad it's over with my ex, but we stay afloat cause you're my index. Seeing clearly now, don't need Windex. Zooming in once and forward, I don't need the context. I know less is more when you keep my data in check. Hey, I think you're the best for me. Hey, cause you help me see. Whoa, cause you're my index. Whoa, my data's in check. Whoa, cause you're my index. Index.
Hello and welcome everyone, and we are happy to greet you here together with us. That's Alex Volochnev, developer advocate at DataStax. Today with me, very special guest, Jeffrey Carpenter. You must know him if you were reading Definitive Guide on Apache Cassandra. That's his book. Hi, Jeff.
Hey, Alex, how are you?
Yeah, very good. Happy to be.
It's been a while since I've been live on a workshop.
When was it?
Here.
When was it?
Well, I don't want to say, but it was pre-COVID, I guess. So we did a lot of things in person back in the day, but we did a good amount of online workshops too. So I'm glad to be back joining you today. Do you want to introduce some of your credentials here,
well,
friend?
not really. Usually we have a lot of returning guests, people who attended our workshops before. So hopefully I don't need that. And you know what? Let's introduce ourselves again in the end. But first, people care about the code. Talk is cheap. Show me the code.
Yeah, that's right. Okay, well, we're definitely going to get there today. So we put some contact information out there. You know that you can reach us on Discord, direct out there. We're monitoring the YouTube chat today. So you can reach out and connect with us. And toward the end, we're actually going to give you the opportunity to reach out and grab some meeting time with us. And I should also mention we have some of our usual crew of advocates helping us out on the chat with the support today, as well as Chris Bradford, who is a leader on the Cassandra team, is kind of out there and monitoring. So bring us your your most detailed questions, and we'll just redirect them right to Chris. And he's like, "Cursed you, Jeff." All right, with that, you know what? I have the mic, so I can do that. All right, here's our outline. Man, we have a lot to cover today. I'm not even totally sure if we can do it all, Alex. Maybe it's a matter of how much I talk. So we're gonna go through some quick Cassandra and Kubernetes basics, and the whole point is not to reteach you any of those technologies, but to highlight some of the connection points. So we need to give a little bit of context in order to do that. And then we're going to go through the various elements of what Cassandra is giving you in terms of installing and running a Cassandra cluster, but then also doing some of the things that you need, giving you access from an app dev perspective to various APIs, including your standard CQL API, but also some fun new stuff through Stargate, and then some of the operational tasks that you're going to want to perform. Alex, your master plan of outline here, I'm just going to do the reveal right now. We're mixing operations and developer topics. So it's going to be like a little bit of something for everyone all the time, keeping you on your toes, no matter what your preference is. So should we just do it?
Yeah,
should we start?
Absolutely. And I want to notice what, working in development for many years, I'm really tired of ops people who care only about ops, and really tired of devs people who care only about devs. That's completely wrong. You have to understand other parts of the development to be efficient engineer. So take a look at all the steps we are going to do with you today.
Okay, good. I feel totally debunked, but also you're correct. Do you want to talk about the homework and how we're going to do exercises for this particular workshop, Alex?
Yeah, so take a look. We are going to try something new. Well, not something you asked us for a while already. So take a look. Today we'll do the live demo of the things we are doing with Cassandra and how it works. But we want you not only to watch, but we want you also to touch. That's very important. Practice, theory without practice is just dead and often useless, and you forget about everything the next day. So we want you to put your fingers on the keyboard, push the buttons and work with it. If you have more or less reasonable sized machine, so you can run Docker, small Kubernetes cluster on your own is great. If you don't, we are even ready to provide you a training cloud instance for free. So you can go and do the workshop steps on your own, ask your questions on Discord or ask your questions later after the workshop. Yes, ask your questions at the community. And then if you do all the steps, you send us the screenshots. And Jeff, could you please push the button?
I would love to push the button. Oh, there you go.
Yeah. And then for those who are making the practice, who makes the workshop today, they will receive a special badge on LinkedIn from DataStax Developers confirming where he or she successfully passed the workshop, did the homework, and got the fundamentals of Apache Cassandra with Kubernetes, proved by DataStax Developers. So that's not a big certification, but it's free, and you only have to invest your time and upgrade your skills. So that's, I hope, make you very interested to make this happen. I know what a lot of people were only watching workshops but not doing practice. We are going to fix that. Now you are going to do the work. Not only we do the work, but you too. I like it.
All right. Good plug. We'll talk more about that. We'll bring that back to you at the end. So yes, if you want to follow along right now, you know, we've given you the link on GitHub, but it's probably better to watch for right now. I would take Alex's advice. Okay.
Yep. So let me switch.
So let's get this rolling with some fun.
Yeah. So today we, as usual, have a quiz, so you can answer the questions and then some swag. And as usual, we use menti.com, but first we are going to ask some questions. So easiest way to answer the questions of our quiz and answer our setup questions. Oh, Jeff, sorry, let me shrink you for a moment. Oops, wrong.
Hey,
button.
Nobody puts Jeff in the corner. Sorry, Dirty Dancing reference, 90s. I mean, it's been a long time.
Yeah.
Maybe I should stop my old man jokes.
So, jump in with your best way to join Menti is just open it on your mobile phone with menti.com and enter the code 7162049 or just scan the QR code close to Jeff and you will be in, you will answer our questions, we will realize who have joined the workshop and we will start. So, first question is, what's your experience with Cassandra? Is it a database? I have some understanding. I use it regularly. True guru here. Okay, so looks very not bad. I see some people have not so big experience, let's say. Is it a database? Yes, it is. It's a great, very powerful database. Use it on the biggest and most interesting and most lauded projects in the world. If you are using Apple, you actually already using Cassandra. You are watching Netflix, you already using Cassandra. Oh, you don't like Apple, you prefer, for example, Huawei, the biggest Cassandra deployment, I would say, and so on.
Wow,
so Instagram. Yeah, Instagram is also runs really a lot of
We have
Cassandra.
a new leader on the worldwide usage, huh?
Yeah, indeed. It was Apple before, but now we found out what Huawei is the bigger one than Apple in the questions of Cassandra usage.
Oh, yeah.
So if you are a beginner, listen very thoroughly to what Jack says in the beginning, or Jeff says, sorry, in the beginning. Then next question, what's your experience with Docker? You know, this workshop is about running Cassandra in Kubernetes. So if you never heard about Docker, it must be a little bit hard for you. Oh, we have some Docker masters here. It's great. And people, if you have some understanding or use it regularly, you will be fine. If you're a Docker master, then that's great. Help us answering questions on the YouTube chat or in Discord. And finally, if you never heard about that, well then it's going to be a rough workshop experience for you, because we are talking about pretty complex things. But you know what? We have a special Docker learning path for those who are complete beginners in Docker. So maybe some of my colleagues would be so nice and put the link to our Docker learning path. That would be great. And then last question before we proceed. What's your experience with Kubernetes? So we know how much you are into that. Okay. So we have people with Kubernetes understanding, regular usage. Oh, Kubernetes rockstar, great. And we have some people without Kubernetes experience, which is fine. So it's not a Kubernetes course, but follow us, then add the Kubernetes workshop from Docker Learning Path, and you will be fine. No worries.
Oh yeah, that's a good point. You've done a great series. I think you probably qualify for the Kubernetes Rockstar. I do not.
Well.
Getting there. I'm getting my Kubernetes foo on.
Kubernetes is a very big topic, and like Kubernetes experience in the different environments will be very different. So it's always complicated whom to consider a master or not to consider. Doesn't matter. I think we are ready to start. So now I see a few dozens of people join at Menti. That's incredible. Now don't quit, because quiz starts soon. And now we are switching to the slides. So hi Jeff, now it's your turn.
Okay. Get that screen transitioned over, and we're going to be talking now about just enough of the basics of Cassandra and Kubernetes to start thinking about how we tie them together. Okay, I'm going to zoom way super far out here. You know, about 15-ish years ago, we started seeing some major trends in how we were all building applications. We started talking about the cloud and using Amazon Web Services was the first provider where you could actually get access to infrastructure as a service. We started doing all that kind of stuff. We started doing lots of microservice, dividing up these big monolithic applications into microservices. And then, some of us started using these highly scalable NoSQL databases like Cassandra as our data store. So if we think like of these cloud applications as having application code and data, and then running on some infrastructure, like at a very high level. Now, what's started to happen is that there are some architectures that have really and some combinations of technology, let's say, that have really risen to the forefront as the ways to build highly scalable systems. So we see lots of companies building out microservice tiers that kind of running in large data centers that they can scale up easily using infrastructure like Kubernetes, and then they might build their web and mobile applications on top of those microservices. And then those microservices might be getting their data through a database like Cassandra. And we're also starting to see the emergence of this idea of a data gateway, which is brought to us by Stargate. That's something that we'll talk about toward the end of the workshop, hopefully not much more than an hour from now, or maybe less. And then as a way of really getting a lot of automation around application deployment and operations, we've done a lot of deployment of microservices and even other applications using Docker and other containers, and then we needed something to manage all those containers. So that's where we got Kubernetes. And then all the major cloud providers have a Kubernetes environment, hosted environment that they provide, or you could do something like VMware Tanzu, or just kind of run it in your own self-hosted environment. So you can do Kubernetes everywhere, in your own data center, in the cloud, or both with multi-cloud, that kind of thing. So this is sort of the landscape. Now, one of the problems that we've seen is people using Kubernetes for their application tier and using that to scale out, and being very happy with a containerized application layer, and then running a separate Cassandra cluster outside of that. And so a lot of people have been asking us, how do I run my Cassandra cluster in Kubernetes alongside my application code, so I can automate the deployment of all that stuff together as a unit? And some people have definitely made some progress kind of working on their own, but we as a community have really come to the conclusion that we're going to get farther a lot more quickly if we work together. So that's when the Cassandra community and others started working on various operators, and the Cass operator as a unified operator. Don't worry, we'll talk about what that means. And the Cassandra project as some glue on top of that operator that glues Cassandra together with tools that make operating it more effective and easy, and making it easy also to build your applications on top of it. So we're trying to help provide an integrated package for everything here. So that's some of the context for what we're doing and why. So now we want to talk about Cassandra. So it's been around for over a decade now as probably the most scalable NoSQL database that is out there. So we have a Cassandra cluster, and that would consist of multiple nodes. And your mileage may vary in terms of how much data and throughput you can get out of each individual node based on your particular use case. But there's some approximate benchmarks, and including the very approximate benchmark of lots of transactions per second that we see here on the slide. Basically, to scale up a Cassandra cluster, you just add more nodes. That gives you more storage, and that gives you more throughput in terms of the number of and the quantity and size of queries that your cluster can support, whether it's reads, writes, a mix of both. Now, these one of the awesome things about Cassandra is if these nodes are networked together, if they can see each other, then they communicate in the background using something called gossip to self-organize. This allows the cluster to self-heal and also to route around a node that might not be performing very well for various reasons, or even to route around if there's a network partition, let's say, and some of the nodes can't see each other. Cassandra has a lot of mechanisms built in that keep it very reliable for that. So we have this concept of the nodes being organized in a ring. This organization allows Cassandra to scale linearly. This is a chart that some of you may have seen before. Cassandra literally scales like this. So there are technologies where you sort of get diminishing returns from adding additional nodes because the communication overhead, for example, within a cluster might start to bog down. Cassandra is a great technology in that it demonstrates a linear scalability. So this is something that begins to make it very nice to pair alongside a scalable application architecture, like if you have multiple containerized microservices that you are scaling up and down the number of service instances, let's say in your Kubernetes cluster. So these begin to parallel each other in terms of their capability at the application tier, at the database tier. The way that Cassandra works is that as you add nodes, it distributes the data out. It uses the way that you define your database schema in Cassandra. Cassandra uses that to partition the data and to store it out to multiple nodes. Now, this picture does show that distribution. We'll see another picture in a second that shows how Cassandra is distributing actually multiple copies of your data for high availability, and so it can survive the loss of a node without losing data. So let's talk about how that replication works for just a second. The fields that you identify in your database schema as being the partition key get hashed together, and that data is used. Cassandra uses that data to figure out where to send, which nodes should own your data. So if you have a replication factor of 3, there will be a node that is the main owner of that range of hashed values, and then the nodes that are adjacent to it will also in the ring, basically. So this is a conceptual organization. Each node is taking ownership of a portion of a hashed value. We've represented it on this slide as being a range of 0 to 100, but it's the actual range is much larger. But for illustration purposes, we're saying using this smaller range. So what happens when you insert a piece of data? Let's say that I'm inserting a row of data. The partition key value hashes to the number 59. Cassandra is great because I can route a write to any node in the cluster. So when I do that, let's say I send it to that orange node on the right that's marked with 17. Through gossip, that orange node is aware that the 3 nodes that should own that data are the 3 nodes that are on the left there, the black node marked 0, the light blue one marked 83, the purple one marked 67. Those are the 3 nodes that should have a copy of that data. And so the orange node sends it there. Cassandra is also really resilient to failure, and it has multiple mechanisms that are built in for keeping your data reliably. So occasionally a node goes down. Could be a hardware failure. Could be that your cloud provider killed that virtual machine that it was running on. Could be a software error. Things happen in large distributed systems, right? So that node has failed. Cassandra has multiple mechanisms that are built in for reliability. If a node is down for a short time, we can store a hint, and then when the node comes back online, the orange node can send it the copy of the data and be very happy. However, the hints are not kept forever. And so there is another mechanism, a backstop, that is called repair. And we're going to come back to that theme in a little bit as one of the key operational things that Cassandra and a tool called Reaper are going to help provide for you. So I showed you a ring view of Cassandra. Now I'm going to show you a second view, which is called data centers and racks. So we'll call this the topology view. So in order to maintain high availability, you're going to run your Cassandra nodes and spread them across your infrastructure. The terminology here is very sort of reminiscent of the days in which we were all running our own on-prem data centers. So you see this data center and rack terminology. In the cloud world, we might think of a data center as being equivalent to a cloud provider's region, and a rack being equivalent to an availability zone. And we're going to see mapping of this onto Kubernetes workers in a little bit that are distributed throughout a Kubernetes cluster. So this terminology is important for us to kind of understand the mapping, right, of how these ideas of Cassandra data centers and racks map into the Kubernetes world. The other thing you'll notice here is that there's some intelligence in terms of organization of the different nodes and the assignment of those nodes onto the racks. And this is generally done in such a way so that you actually have a copy of each piece of data within a rack. So if I have a replication factor of 3, I'm storing 3 copies of every piece of data. Cassandra is going to use its awareness of how the nodes are assigned to racks, such that I have a copy of the data on a node in rack 1 and in rack 2 and in rack 3. So these are smarts that are built into Cassandra itself, we don't have to think about them as long as we configure our cluster correctly. And that caveat, the if configured correctly, is something that Cassandra is going to help provide for us. So some more selling points of Cassandra is that it is not limited to a single cloud region. So you can have multi-data center or multi-region deployments. And again, if you set your networking up correctly between clouds, you can have hybrid and multi-cloud deployments of Cassandra. So not just AWS or not just Azure or not just Google Cloud, but you can join any of those clouds up with nodes in your on-premises data center to get data replication to multiple locations. So this makes Cassandra a really great fit for flexible cloud deployments. And we could talk about use cases for Cassandra literally all day, because that's kind of what we do. So, but just a couple of the references. I wish that we had a Huawei slide in here, Alex. We need to get that added.
Yeah, definitely.
But definitely two of the earliest adopters are and massive users that are known are Netflix and Apple. And these have been deployed Cassandra in production for a decade or more.
Yep. Interesting point. What they all are not only using Cassandra, but they also contributing heavily. So both Apple and Netflix did such a great job getting their version 4. It's incredible. Instagram, Netflix, Apple, they did a great job to deliver many great updates, improvements, features into the Cassandra version 4. So that's really cool.
Yeah, definitely. I mean, we definitely spent a lot of time talking about great engineering work that was done not only at DataStax, but companies throughout the industry. So I hope that we definitely try to represent them well. All right, so switch gears to Kubernetes. I'm giving you a couple of teasers there about Cassandra. So Cassandra is basically a container orchestration tool. So it's going to allow you to deploy containerized applications, scale them up and down, upgrade them, keep them running, replace things that fail, have high security around those. So it's a great environment for that. And it's funny because in terms of running a database in a container, Alex, you probably know this, but like when I did the first, I didn't write the first edition of the Cassandra book because that was done in 2010. But then in about 2015, 2016, when I was writing the second edition of the Cassandra book, someone had suggested to me, oh, you should probably talk about Docker and running Cassandra. And I was like, yes, I will do that. And I'm going to recommend that you don't do it. And that was about 2016. This is like, if you want to be bleeding edge, sure, go ahead and try to run Cassandra in a container, but do that at your own risk and let us know how it goes so we can learn from it. The world has completely changed since then. So when I did a third edition of the Cassandra book last year, and I had to add a completely rewrite the Docker section. But oh, by the way, there was this whole new thing called Kubernetes that I had to account for. And so, I mean, it's great. It's great to see the technology move forward in this area. And we're going to talk a little bit about some of the things that have been added into the Kubernetes world over time to make it easier. So we have this motion, a lot of people have deployed Cassandra on bare metal, and then on virtual machines, it's no problem, right? And then this motion toward deploying it on a container where you have a very minimal, a very thin kind of Linux layer. That's what most of us are going to be using in terms of a Cassandra container that is just providing a little bit of networking and file system, right, data storage access. I have to slow down so Alex can add any color that you want to sometimes.
Don't worry, if I want to add something, I'm able to interrupt you.
I won't be able to stop you. Is that how it is?
Yeah, like that. That's okay, a long joke, so you just start a special workshop Alex talking about Cassandra in Docker, and the next stop is going to be approximately in 26 hours.
That's right. We have a whole workshop for that, is what I'll say for that. All right, so some of the key differentiating features of Kubernetes, it allows the deployment and scaling up of pods, which are basically different containers that are running inside the context of these pods. You can have pods that are kept up and running all the time, or you can actually do kind of job style execution. It does very efficient packaging of containers. There's a scheduler built into Kubernetes that does a very nice allocation of containers based on the resources that they need. There is a detection of what nodes are up and down, and where we are running things, as well as the containers that are running on them. So there's a lot of self-healing kinds of capabilities. And then there's a lot of security features that are built in. And there's a growing amount of support for being able to do storage and represent storage on Kubernetes. So that's really a key enabler for Cassandra. So just to quick introduce some of the parallel terminology. I will try to be careful when using the word cluster, because Cassandra organizes its nodes in clusters, and so does Kubernetes. And I guess sort of Kafka does too, right? I mean, it's a common terminology for a distributed system to have, multiple compute nodes where work is taking place, and those to be organized in something called a cluster. So, within a Kubernetes cluster, there is a machine that is the master. There's concept of a master, which is running a bunch of control plane components and providing a REST API that you can use to interact with the control plane. And then there are worker machines or nodes where your containers are actually deployed and are running. So if we are going to drill into what is inside the control plane, there's this API server, which I've mentioned. So all the interactions with the control plane go through that API. The containers that we are running inside pods, they communicate through the API server, and any tools that we are using, kubectl, that we use at the command line, that's going through the API server as well. So that's kind of that sits in front of everything. Within that, there is a controller manager. So it has a pluggable architecture for adding different controllers. There's some built-in controllers in Kubernetes. And then for the purposes of Cassandra, we're going to see how there are some different managers that get plugged into that architecture. And then there's also a scheduler that I've mentioned that distributes the work of different containers onto the nodes in your cluster. And then etcd is used as a backing store for all of the information about what is deployed within your Kubernetes cluster. And then if we drill into what's happening on each individual worker node, there is a little process known as the kubelet, and that is in charge of running all of the Kubernetes related things on the node. It's in charge of talking to the container runtime, whether it be Docker or containerd or something else that is running containers on that node. And then there's a proxy that provides networking services to basically to expose out network access to each of the individual pods within that worker node. A pod is generally most often runs a single container, but it can run multiple containers within that deployment. And so the pods are the things that are being monitored by the things in that control plane in order to keep them running. All right, so now that you understand everything about the architecture of Kubernetes, let's see if you can deploy a Cassandra cluster on Kubernetes. We'll give you the rest of this workshop, approximately 90 minutes. You should be laughing at me. And saying no. That's probably not something that you're going to be able to cobble together in that amount of time. What you're laughing, Alex?
Yeah, I mean, I like the idea to cover the whole Kubernetes within 90 hours. 90, not 90 minutes, but 90 hours. That still would not be enough.
No, but seriously, like this is all you have to do, right? So we need to deploy a network. We're going to configure some Kubernetes storage. We're going to install Cassandra on some individual nodes. We want to be able to monitor them and grab metrics from them. So let's see if we can get Prometheus and Grafana deployed. We actually want to have agents on each of the nodes for the purposes of metrics of the Cassandra nodes, for the purposes of metrics reporting. And then that's not even to mention any of the operational tasks that we want to get set up so that we can have a well-maintained cluster. Haven't even talked about connecting an application to it. I mean, there's a ton of work here. So obviously, we're just kidding. We're not going to manually do all of this. We're going to use some Helm charts, package manager, basically for Kubernetes, from the Cassandra project to get all this deployed up and running.
Yep. I always say it, what best developers is lazy developers. Because,
Lazy
well, we
developers.
don't want to do it again and again, so we better automate everything. That's what Cassandra and Cass Operator and our tools are doing. They help you to be lazy, they help you to stay efficient. It's done already so many times, why would you do it manually again?
Yes, that's right. That's right. And Kubernetes is a declarative system. We want to tell Kubernetes, the control plane, what it is that we want, what we would like our environment to look like, and then let it do all the work of deploying all those things and wiring everything up. So Kubernetes is great, and we need a little bit of help on top of that. So that's why the Cassandra project exists and what we're going to be talking about next. And you were like, "Hey, I know that a half an hour ago we said, you said, show me the code, Alex." We're getting so close.
Yeah.
All right. So think of Cassandra as a full working scalable database with admin tools and easy data access. So making Cassandra into a cloud native database. So I'm going to introduce the components a little bit at a time. First, we're going to kind of look at this from a developer perspective and then an operations kind of perspective. Yes, you very well may be the person that cares about both. So at the core, we have Cassandra, scalable database. There's a Cass operator, which will show you how that works and what that provides. On top of that, we have the ability to layer Stargate. That's a data gateway, provides REST, GraphQL, and document APIs. And then if you need to be accessing either the Cassandra query language, CQL, or any of those Stargate APIs outside of the cluster, you may want to set up ingress so that those services are exposed outside of your Kubernetes cluster. So in Cassandra, we've provided traffic as the default implementation of an ingress. Now, thinking about operations, we provided 2 projects that were originally developed by The Last Pickle and Spotify and others, called Reaper and Medusa. So Reaper is something that helps manages Cassandra repairs, and Medusa is for managing backup and restore of Cassandra's data files. So we've integrated those 2 open source projects. Everything in Cassandra is obviously an open source project. And then we've included Prometheus for aggregating the metrics as part of the collection process of metrics, and some Grafana dashboards that we've built to help visualize the metrics about the health of your Cassandra cluster. So that's all packaged up together as part of Cassandra. And then that packaging, basically, how this is deployed is as a series of Helm charts. So it's a really composable, pluggable kind of architecture. There's kind of like that parent Cassandra project that then pulls in other charts, like those that deploy the Cass operator and Reaper and Medusa, and so on and so forth. So think of accessing this in a couple different ways. If you are a developer, you're probably thinking more about the API side of things. And your users are accessing your web and mobile applications, which are built very often on top of microservices, although you could have apps that do direct API access, and that those are exposed again through that ingress. And then you're accessing, through the data gateway, getting to Cassandra for all the data access that your application needs. On the operator side, which you see on the right, they're using Helm to deploy those charts into the Kubernetes cluster and able to view metrics through Grafana and to manage the operations of the cluster through interacting with UIs that are provided by Reaper and Medusa. And then Medusa for cloud backup, we have a pluggable architecture for where you want to actually store your data files to object storage. So the most recent release of Cassandra, the 1.0 release, includes the S3, right? And then we're working on others. Okay, so setting up Cassandra is pretty easy. We see the basic commands here on the upper left. We're going to make sure that we have Helm installed, and obviously the Kubernetes cluster where we're going to be deploying. And then we'll add the Cassandra Helm repo and the traffic Helm repo if we're going to use traffic. And then there's a simple Helm install command, which Alex is actually going to demonstrate for you here in a second, referencing a Cassandra YAML file. And there's an example of what that file might look like here provided to the right. These URLs on the lower left are the more full getting started guides. There's a basic getting started guide that'll just help you install the charts and get it going. And then there's a developer specific path that'll get you started on using Stargate, and a site engineer path that'll get you started on doing some of the operational tasks. But you know what? It's time.
Yeah, it's time.
It's time for some demo.
Like, sorry, Jeff, I know you're a great guy, but you are talking and talking with slides and slides, and like, where is the console?
Here's the console.
Here's the console. It's time. So give me a moment to switch the things to my screen. Boom. So I'm going to tell you a couple of things before we start with the demo. Again, that must be a practice not only for me, because, well, I know how to install Cassandra. I'm not doing it for myself, I'm doing it for you. And to get the most benefits out of that, you first watch, and then the workshop is over, you do it on your own. If you have any problems, you contact us at Discord or, well, preferably in Discord. So, what's important for you? Workshop idea, that's the repo. I guess it's been pasted already on the YouTube many times. Let me do it again. Oh yeah, I see. Thank you, David. So that's the repo. And doing this workshop is a 3 simple steps. So first one, watch the workshop on YouTube. That's what you are doing right now. Thank you. Then do the practice steps and ask questions using our chat or our forum. Now regarding the practice steps, it's all described in our wiki. So wiki of the project DataStax Devs Cassandra workshop explains all the steps you have to do. And to do the steps, you have 2 options: local setup or our cloud instance. If you can do it locally, great, because you have no limitations. You see, these cloud instances pretty expensive, and we give them, they are sponsored by DataStax, so we cannot give them for so many people for a long time, so they will be very limited on time, usually 24 hours only. And therefore, if you prefer to keep it on your pace, do it over the weekend, you better do it on your machine if you have a proper machine. So we suggest at least 4 cores and 8 GB RAM, but frankly speaking, you need more to have some of that better working. So if you need provided cloud instance, contact Alex, that's me, in case of any questions. So you can require one, you can ask for one using this link or contacting me on Discord or using my email address if you have this one. But well, this link is easiest one. Or you can go on with a local installation. With the local installation, what you have here is install missing software before we start. List is pretty obvious for the Kubernetes-based tool. First, you are going to need Docker, no questions. When you are going to need Kind, if you are following our exact steps. Kind is a Kubernetes and Docker local installation of Kubernetes. Bad for your production, but very good for testing, learning purposes, so things like that. Then kubectl, Kubernetes control command line tool, pretty obvious. You cannot manage Kubernetes without kubectl. Last guy is Helm, and Helm is obviously package manager we mentioned already. Then you will need this repository, github.com DataStax Devs. We have everything prepared for you. And finally, you will have to start with cluster, with kind create blah 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 blah, kubectl cluster info blah 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 blah. And then you will be good to go. If you are using cloud instance, situation is a bit different. If you are using cloud instance, you have to connect to this cloud instance and everything is installed already. So how to connect? Very easy. There are two main options. If you are using SSH connection, if you have Linux machine, bash terminal, and so on and so forth, you can just use SSH command, use user esc2-user, password DataStax, and you are good. If you have Windows, you may need PuTTY or tools like that. Then, if you cannot use SSH native connection, you can use web-based connection. So we installed even shell in the box for you. Like, well, we did a lot of work actually. So, using the link you will get from me, you will open the first link, SSH console in a browser, and again using the credentials above, and you will be good. So it should be simple. How to check if your instance is ready to proceed? First one, you just issue the command kubectl get nodes. If you have the list like that, so kind worker, worker 2, worker 3, and things so on, then it's all good, you are ready and we can start finally, and that's what I'm doing right now. Again, don't run and don't try to ask all the questions right now. With other companies or with other workshops, you may need to ask all the questions during the live session, but not with us, because we stay available to you. You can contact us at Discord preferably. So, first step, I'm going from wiki to the step 1, and it's here or on the right side. And I'm going to setting up Cassandra, Cassandra. So I will move this screen a bit to a side so I can start with my terminal. And I will make it a little bit bigger so you will be able to see that. And you know what? Hey Jeff, I'm going to move us a little bit so I will not hide the code and you will not hide the code as well. So now we are close neighbors, but keeping social distance, okay?
Well, that didn't hurt at all.
Yeah, so good. So how do we install this thing? Situation is very easy. As soon as we have Kubernetes running and Helm installed, and the prerequisites, installation is going to be very simple. My first step, oops, sorry, wrong button. Yeah, my first thing here is to add repository for Helm. Helm is kind of a package manager. Well, it's not exactly the package manager, but the work principles are very similar to those we are doing. We simply state a simple command, helm repo add. It will be called at Cassandra, and that's what we will use as the source repository. https helm cassandra.io/stable. Boom, Cassandra has been added to your repositories. Cassandra is not enough. At least for our purposes, we need to open some ports, open some services, and show you some things running internally. So I will need one more thing, which I'm going to install. It's called traffic. Traffic is reverse proxy, is an ingress controller in this case for Kubernetes, which makes possible for your queries from outside of a Kubernetes reach internal Kubernetes services. Very easy. Traffic is a great tool. It's pretty new, so I doubt if most of you have heard about that. But I can tell you it's much more convenient to use as an ingress controller than, for example, Nginx. And I'm a big fan actually of Nginx. So if I say traffic is interesting, well, then it matters something.
And that does answer, I think, one of the questions I saw in the chat earlier about how would you access the Cassandra nodes from outside the cluster, and the using ingress like this is the answer to that.
Yeah. So of course, as any normal Kubernetes system, there are multiple ways you can reach the application. I don't know, node ports. Hope you don't do it on production, but still it works. And other ways, and we recommend to use ingresses and specifically traffic, but you can do it, of course, using another ingress tools, what you would prefer to use. This workshop uses traffic. And finally, we added those repositories, but it's not enough. So we have to issue a command helm repo update. And we see what some messages here. Successfully got an update from traffic chart repository. Successfully got an update from the Cassandra chart repository. I hope it looks, I hope it looks good for you as well. And we can proceed. Question is, can we name anything, or it's mandatory to use Cassandra? So take a look. Nothing is mandatory. You are an adult person with free will, so feel free to name it whatever you would like to. But for the clarity and for the simplification purpose, I would suggest during the workshop, follow the default, follow the suggested names. And if you're brave enough to change something, we may try to help you, but well, better follow the rules in this case, okay? So,
totally.
Yeah, next thing we are going to do is we are going to helm install traffic. So we updated the repository, and now we are going to install traffic. That's going to be pretty quick. And now I can say watch kubectl get pods. And we see what only one pod is being started. It's going to be ready very quickly, so usually it takes some seconds. And while it's ready, and while it's being opened, let's take a look at what the file was. So what's the file we are using for this one? All files are present in the repository, obviously. And in this case, we're using traffic.yaml file. That's a configuration for traffic, which helps traffic to run the things. So that's, as it's a kind of router, it's all about which ports to open, which ports to listen for which service. Very simple. We are opening a lot of ports, and in this case, as it's learning environment, we are using node ports again, but with ingress service, so it's much easier to use. And we are opening some ports for the Cassandra. So, for example, Cassandra port 9042, Cassandra secure for TLS secured connections, some secret things we will talk a bit later, so Stargate, special guest, and of course, web interface and traffic dashboard. So with that decided, let's take a look how it looks. And I'm going to open the ingress traffic dashboard. And the link is very simple. That's going to be the your link. If you're using cloud instance, I will send that to you. It will be port 9000 by default using our settings, and then you have to push dashboard. One very often happening mistake, if you just skip the path, traffic says you page not found. So don't forget to put the page. It's just dashboard, and then you, dashboard with slash in the end, that's important. And then you get traffic dashboard. And there are already pretty a lot of things running. So traffic consists of entry points, routers, services, middlewares. Traffic works with HTTP, TCP, and UDP. Today we will talk mostly about HTTP. So routers are the ideas, the set of rules. Those will route your request to a proper tools, proper services. It's the default installation of traffic. Nothing is running except of traffic, and therefore we have only two services, only two routers for dashboard. That's where we are, and second one is just ping, which is out of scope for today. And there are some internal internal traffic services. Again, mostly dashboard. What's interesting for us for today. So with traffic running, so I see there are some questions we have to answer. Are there any questions we have to answer now? Nope. Okay, looks like we are good to go. So
this is a question about port conflict. Are these ports conflicting with other well-known ports on Kubernetes deployment? Do you see that?
Someone is trying to do the exercises already. Let's keep it for later. Let's move on. So traffic is running, but well, traffic is not enough. It's only the ingress, and we want to have something behind ingress. We need Cassandra. So it's time comes for us to run Cassandra. It's going to be very close to the things we did before. It's going to be very simple. Helm install Cassandra from repository Cassandra. I ask Helm to install Cassandra for me, and as a configuration file, I will use Cassandra YAML. We will take a look at this file in a moment. First, let's start settings. First, let's start to set up the things. And after some seconds, usually it takes not so long time, we get the notification what it's being deployed or deployed from the Helm point of view. Oh yeah, here we go for Cassandra. So for traffic and for Cassandra, it's revision 1 status deployed. Okay, so let's take a look what's going on. The core of Cassandra is Cass operator. So Cass operator is the application, Kubernetes application, which helps with all the routine operations on your Cassandra or Cassandra cluster. For example, you want to change a setting on all of your nodes. You can do it manually. You can go to the first node, change the setting, restart it to apply the setting if a change requires that restart. And then you have to go to the second one, to the third one, and so on. With Cass operator, you change the settings for the cluster, and Cass operator will not just restart the whole cluster, but it will apply the rolling update for all of the nodes one by one, so you will always have your consistency level reachable, which is great. So this stateful set is Cassandra by itself. So it's a Cassandra and Cassandra management API running together. It's not yet ready because it takes time to start up for them. Then about Stargate we will speak in a moment. Grafana and Prometheus are monitoring tools we will use in the next step. And Reaper operator we need for repairs, as mentioned already. And Prometheus, Cassandra Cube, Cube Prometheus is to manage, obviously, Prometheus and Grafana stack. And traffic, well, you've seen that already. As the thing goes on, let's take a look at the file we are working with. So, what's the file and how it looks and why should we care? Cassandra file in the repository is the very important file which describes the whole cluster setup. First of all, and the most important part for us, is the settings for Cassandra. Which version we are going to use? Which storage class we will use, because, well, we are working with stateful sets and that's very important to have proper storage class, persistent volume claims, and so on. Which size it will have, some heap and Java settings, resources allocation, and finally, what the amount of the Cassandra servers we are going to have. So we will have only one data center 1, only one rack, name it default, and one machine in this rack, one Cassandra node in this rack. Well, Stargate, I will skip it for a second. Reaper as well, we will get back to them, don't worry, I'm not skipping them at all. I'm going to back to them soon. And there are downstairs monitoring settings. So, the most commonly used monitoring tool set to watch, to control Cassandra is Prometheus and Grafana. Prometheus to get the time series data metrics from Cassandra, and Grafana is to visualize them, have nice dashboards, alerting, and so on. There is a question, why do we use Prometheus to store metrics from Cassandra? Idea is very simple. If we store Cassandra metrics in Cassandra and Cassandra have problems or down for whatever reason, we will be not able to get in even metrics. So the golden rule, store your metrics in another place, not in the place you are monitoring. Very easy. So I hope it's already fine and I'm perfectly right. So Cassandra is running. Here we go, both containers in the pod, one for Cassandra and one for management API. There are some things meanwhile happening. Reaper has been deployed over our Cassandra cluster. So we have Reaper schema distribution completed, Reaper operator running, and Reaper for Cassandra running. And Stargate is starts. It takes some time, so we will discuss that some moments later. So we are ready to move on. Our next step would be, we have to verify.
It doesn't actually start Stargate until the Cassandra nodes are up, just by the way.
Yeah, it makes no sense.
Yeah.
We cover that a little bit later. So, and finally, we want to do some things. We want to take a look what's going on. By itself, Kubernetes operates with pretty primitive ideas. Deployments, replica sets, pods, services. It's all great. Those are very, very important bricks we use to build the system. But complex systems, complex distributed systems like Cassandra, they are powerful, but of course not simple to manage, require a lot of attention, require a lot of things. To avoid you doing all the things, and to help you avoid doing all the things manually, there is a great thing called customer resource definition in Kubernetes. With customer resource definition, you can describe what you want with one single definition, and it's way much easier to try to keep in the air like dozens of the more simple concepts. So what's Cass operator, part of Cassandra introduces, is Cassandra Data Center. Cassandra Data Center is a customer resource definition with description of a Cassandra data center. Very easy. And kubectl get Cassandra data centers shows me what we have one. It's active for 6 minutes, and we can, for example, say kubectl describe, and boom, there is always dozens lines of the information, because, well, there's pretty a lot of work done and a lot of things included. But what's important for us, it works. There is a Cassandra data center, and it uses Helm chart Cassandra 100. And that's actually great because we already have a lot of things running. And that was the installation. And in the next part, we proceed with monitoring. But I guess, Jeff, it's your turn now.
Wow, already.
Yeah.
Okay.
Well, I can
So we'll
I
flip
can
back over.
I can keep speaking. I can keep speaking.
I'm just trying to give you a hard time because you were talking about how long I talked. It's how I get you back.
Well, you know, working
So when you go,
working with Kubernetes is always hard time, but you kind of enjoy it. So I'm switching to your screen then.
Okay, great.
Boom.
Okay. So I wanted to tell you a little bit of detail. I'm not going to explain all of the objects and all of the pictures on these next couple slides to you, but I wanted to help maybe tie together some of the terminology. So in Kubernetes, there is a construct known as namespaces that is a very useful tool to scope things. So the name that you picked for your Cassandra cluster, we defaulted it to Cassandra for the purposes of the demo that Alex was running. So all of the infrastructure that is sparked by Cassandra is it's all placed into a Cassandra namespace. So that allows us to actually isolate that set of components down and look at them all together at the same time. Okay, life happens. My guy at the door, I think, has been dispatched. So, also in Kubernetes world, I mentioned earlier that we have how there is increased maturity in the Kubernetes world for how we're managing storage. So we have this concept of a persistent volume where you can actually configure a block of storage somewhere that you're making accessible to your Kubernetes cluster. That's a persistent volume. And then you can have applications such as Cassandra that are making persistent volume claims, saying I need access to a certain amount of a certain amount of storage that I want to be able to make use of to put my files on. And so then Kubernetes provides the mechanisms for linking together those persistent volumes and matching them up with the persistent volume claims. And then basically you can have this concept of a storage class, which describes different types of storage. So different applications have different forms of storage needs, and so you have different storage classes for those. So part of configuring, if you just want to, part of what the instructions show for getting started is if you're going to run Kubernetes on basically like a desktop distribution, there will sometimes be a little bit of a step that you need in order to have a storage class made available on your desktop machine. So I don't think that was something that we dwelled on very much in the instructions, but you may run into that a little bit later if you're trying to do this on your own. Okay, so stateful set is a group of pods basically that are configured so that they actually have some storage needs. They're using these persistent volume claims, so that this is done in such a way that if we actually have to kill a pod and restart it, we can actually make a replacement pod that connects to the same storage that was used by a previous pod. This is a great thing that we want to be able to do in a Cassandra cluster. So if you have a case where a Cassandra node goes down and we want to replace that node, we want to actually be able to point it to the same storage volume where the previous data files were stored. And using these stateful sets allows us to do that within Kubernetes. Kubernetes also allows us to extend it, so we can define our own resources on top of the basic resource types that are provided by Kubernetes itself. So what I'm showing you on the upper right here is the idea of a resource, a custom resource that is known as a Cassandra data center. So this is actually defined as part of the Cass operator project. I can have a Cassandra data center resource that we can operate on. So Cass operator is a Kubernetes operator that operates on Cassandra data centers. We also use this concept elsewhere in the Cassandra world. So the Cassandra Medusa project that manages backup and restore, there is actually such a thing as a Cassandra backup resource and a Cassandra restore resource, and so on. And then the other main piece that we've mentioned a couple times is this idea of an operator. Now, an operator in the Kubernetes world is something that's considered to be part of the control plane of Kubernetes. You can define operators that operate on your custom resources. So the Cass operator is an operator that operates on these Cassandra data centers. And there are other instances of this in the architecture. Is Reaper has an operator, for example. Prometheus has an operator. So this is where you actually, in a Kubernetes deployment, you create these operators. These have the smarts about the particular things about operating your specific infrastructure. So we could very easily just deploy Cassandra nodes to Kubernetes worker nodes using the basic Kubernetes APIs, but we actually want to have some smarts because we want to deploy Cassandra nodes to specific locations or to specific worker nodes so that there's a good distribution of data. We want to control the startup order. If we just start a bunch of Cassandra nodes at the same time, without care, they might get confused. So we want to bring them up in an orderly fashion so that they can initialize their startup and then add another node and let it initialize and then add another node. So all of those smarts about how to do those things are embodied in this operator. And then when we deploy Cassandra, each Cassandra node is deployed in a pod. Now, pods allow us to run multiple containers, but you can also have multiple processes within a container. So both of those deployment options are available. Within a pod that's running a Cassandra node, we are deploying alongside it this management API for Apache Cassandra. So this is another open source project that DataStax has started. What this management API does, does a number of things, but most importantly for Cassandra, it provides HTTP RESTful access to metrics off of a Cassandra node. So we actually, and this is preferable to the normal way that you historically get metrics from Cassandra nodes, which was Java Management Extensions, JMX, notoriously difficult to kind of understand and use. So we're basically, every time we run a Cassandra node with Cass operator and in Cassandra, we're deploying alongside it this little process which provides HTTP access to the metrics. So that's a part of the architecture. All right, so we had a little bit of a joke a while ago about, you know, like if you were going to wire up all of these pieces together on your own, it would definitely take you a really, really long time. So, and all we mentioned in that slide was basically just like normal Kubernetes deployment kinds of things, just like setting up pods and networking for them. The Cass operator is actually doing one level better than even all of the things that we mentioned. It has the smarts about all the things that you need to do to have best practices for running a Cassandra cluster. So it only bootstraps one node at a time so that there's no confusion. It manages Cassandra's seed nodes, which is how new nodes bootstrap themselves into a Cassandra cluster. If you need to do a upgrade, let's say you want to go from Cassandra 3.11 to the upcoming Cassandra 4.0, the operator has the capability to do that, to do the rolling restarts that are required to do those kind of upgrades. It also helps you to manage scaling up racks evenly so that you have an equal number of nodes on basically assigning new Cassandra nodes evenly across the different worker nodes in your Kubernetes cluster. So all of these things are the smarts that you would really need, not just to get Cassandra deployed, but to keep it operational and running. So these are the things that the Cass operator is giving you. So I'm going to allow myself one more architect-y type slide. I love the architecture slides as an architect, near and dear to my heart. But this kind of gives you a concept of what this deployment might look like across a Kubernetes cluster, where we're mapping these. You see the purple idea. The little pink boxes are the Cassandra concept of the rack. So we have nodes that are allocated across these conceptual racks running on different worker nodes within the cluster.
Yep. And question here, should I as a user care and should I manually manage allocation of the nodes over the racks and worker nodes of Kubernetes?
No, this is what Cassandra and the Cass operator are doing for you. So you don't have to think about this part.
Yeah. Well,
you can think about it.
Yeah. But yeah, there is indeed a lot of things taken care by Cassandra.
So I mentioned a little bit about how the monitoring works. Let's actually get a demo of how all of that gets set up.
Yeah. So you have a couple of slides first, I see.
Well, these are the sort of slides that you have as a backup in case the demo breaks. I'm sorry if I'm revealing too many secrets here, but I think your demo is going to work. So why don't we just go and give us the live demo?
Could you please switch to the previous slide for a second? There is a thing what worth mentioning. It's
I absolutely will.
One slide back. Yep, exactly. So as it's stated above, monitoring is done with metric collector for Apache Cassandra. If you are the lucky one responsible for metrics and monitoring for Cassandra cluster, doesn't matter if you use Cassandra, Cass operator, or do you use Kubernetes at all, or you prefer bare metal, old school, perfectly fine. Metric collector for Apache Cassandra allows very important things natively to get the monitoring metrics, the most important, well, actually dozens and hundreds of them, I would say, putting into the things all together at your disposal, and you don't have to try to extract them manually via Gmix or Node tool or whatever. It's already done, open sourced by DataStax. So just jump into the project, give your stars, make your pull requests, and we will be happy to have some support, as it's the community project, open source project. Now I'm switching to myself and yeah, good. So there is a thing to mention. Now we have to take care of the monitoring, and that's a step 2. So monitoring is a big thing, and we prepare it. This topic is not a monitoring. Explaining monitoring with Cassandra would take some dozens of hours, but we want to help you to start doing this properly using tools what we prepared for you. So we use Grafana and Prometheus to monitor Cassandra, to monitor your system with ease. And how do we do that? Idea is very simple. Here in the traffic, by the way, you see how many more services and routers now we have. 10 routers, 10 services. That's because everything has started already. And here in the services, we can find important things, for example, Grafana and, for example, Prometheus. So, great. Let's first take a look at the Prometheus. The idea is very simple. If you worked with it, no questions. If you didn't work, again, don't worry. We have a link for that. It's going to be on port 8080 if you are following our steps with workshop setup. And the path will be Prometheus. Yeah, so Prometheus is here, it's working. You can choose the metrics you want to see. You just can insert metrics from a list. And as said, thanks to metrics collector for Apache Cassandra by DataStax, there are a lot of them. And we can execute that and get some data. If you prefer to have some graphs, you can switch to graph. And again, have some data right here. But you know what? Prometheus is great, and thanks for this incredible project. But we have something better for data visualization. So let's switch to Grafana. How do we switch to Grafana? I'm using my URL for this workshop. I'm using port 8080. There are links explaining that in the wiki. So don't make your screenshots. Don't try to write it down right now. You will be good. And there is subpath called Grafana. I'm being redirected to login. In your case, it's admin. In my case, it's a little bit different because I've changed it for password. And we already have, now if you have experience with Grafana, you should be like, okay, now we have to set up data source. Now we have to set up dashboards, panels, 1,000 of different metrics. It's not easy even to set up the monitoring if Grafana is running already. But you know what, again, God bless automation. It works already. Let me show you. I'm switching to my existing dashboards, and I already have 4 dashboards here. Cassandra Cluster Condensed, Cassandra Overview, Stargate, and System and Node Metrics. So we can, for example, open Cassandra Cluster Condensed and see the metrics for all together, like, well, in the condensed way. So nothing extra, just some nice ideas. And here you can manage already it with prepared variables. So you can group by cluster, data center, or rack. It makes no sense currently because, well, it's single cluster, single rack, single server. But for your production ready, it may be very positive. You can grab multiple clusters or one single particular one. Again, in my case, it doesn't make a big difference because I have only one. You may operate with multiple data centers, multiple racks, filter data using different racks and key spaces, and so on and so forth. And here you see the request served in the cluster, latencies, so all the most important things. We can switch back to the dashboards and open Cassandra Overview. So here we are going to have a little bit more information with different pending compactions, Cassandra cluster data size, how much data you have. I don't have so much. As a stable counts and all the things important for you to manage the Cassandra. It's all ready, it's all prepared, and it works. And we see the node status, what I have my node up and running, and that's great. And it's already completely ready to use. So you see data is being updated. Cool. So in my monitoring settings, we have many screenshots in case if anything goes wrong. But I like the live demos. That's a little bit higher risk, but you get information directly and like look how it happens in a real life. So we have a lot of different things here, And if you are into monitoring, now you may be happy because so many things prepared for you. And if you are not into monitoring and interested about that, well, you know where to start: Prometheus, Grafana, Cassandra. And if you are not into that, you must be bored already. So, Jeff, I think we are good to switch to the next step.
Okay, well, let's swap back over to my
Give
slides
me a
here.
moment.
And
Yep, you are good.
next up, we are going to talk about working with data. I have this Cassandra cluster running. How do I get at it and run some queries against it? So,
Oh, okay.
funny enough, I don't have any pictures for you because I want to see the access. Let's do it. Let's get me back to my command prompt,
Yeah,
man.
indeed. Well, take a look. There are two main ways to work with data: work from application, and usually we use SQL for that, or work from console command line using SQL SH. And we will take a look at the both. So actually it was pretty quick one, and I'm switching back to my screen. Good.
Yeah, sorry, I accidentally advanced the slide there.
No
Not sure
worries.
what's going on.
So, working with data. Today we are going to use the both ways. We are going to deploy an application, see it running, see how it works with the data in Cassandra, but also we are going to jump into the Cassandra node and execute SQL SH statements manually. So we will follow the both ways. So first thing to mention, we have a pet clinic app. Pet clinic is pet clinic comes from Java world, and it's about it's a demo application for multiple technologies. You may have different libraries implementation and so on. In our case, it's I believe that's mostly delivered by Cedric Lundven, our colleague. If you work with Pet Clinic application, Spring Pet Clinic Reactive, say hello to Cedric, he's in the chat. And idea of this application for us, as we are today, is like, let's imagine we are today more of operation guys. It's very simple. It has a front end, single page application, JavaScript, and it has backend, Java. And we will make it working together with ease, very, very easy. Again, we prepared this petclinic.yaml file, which you may just reuse for our practice steps. So let me clear it up, and I'm putting kubectl apply -f petclinic YAML. If you are already into the Kubernetes, you know what's going on. And if you are not, give me 5 seconds to explain. You can give to Kubernetes direct commands. Run these or run that, delete that, set it up like this. But it works, but that may be not the best way. A normal way, you describe what you want to have in the YAML files, and then you just apply them. And that's exactly what we are doing right now. I'm applying this file, and I have my deployment for petclinic backend created. Service for petclinic backend created. I need service because so frontend will be able to communicate with backend. I have deployment petclinic frontend created for the frontend. I have service petclinic frontend created, so service petclinic frontend will be available using ingress, so traffic in our case, and ingress for that is being created as well. We can take a look at this file, and well, that's a typical Kubernetes file which set all the required things up. So we describe the deployments we are going to have, we describe the services we are going to have, and so on and so forth. Good. So let's take a look at the pods. I'm going for watch kubectl get pods, and we have our services here running, or pods here running for petclinic backend or petclinic frontend. We hope we deployed them already. Let's take a look how it works. The idea here is very, very simple. Oops, Yep. So, by the way, notice in the monitoring request for outputs are changing. That's because we are putting some things, we are running some queries. And we have here pet clinic demo up. That's going to be your URL, port 8080. And let's give it a moment to start up. There is Angular. If you're familiar with frontend, you must know that this technology already, or at least have heard something about that. That's a pet clinic application based on Spring and Angular for frontend. It features some owners, veterinarians, pets doing some things, and you see this. It looks like the base was pre-filled for me already, but I can add a new pet. What would be a pet type I want to add? Let's say, okay, I know the world needs a pet type Alex.
I was going to say emu.
Too late.
But okay.
But I can add one more. How do you write it in English?
EMU.
Like this. Okay. Okay, so I am going to Australia. Okay, I doubt if it's a good pet. Well, I'm never sure in Alex, but let's keep going. And we can switch to the owners. We can take a look at the existing owners. There are no one, and we can register a new owner. I don't know, whatever, let it be Jeff, whatever it be, Carpenter. I have no idea about the address, but let it be like that. And city, okay, let it be, I will make you my neighbor. You are going to live in Otterberg now. And well, phone number is not important. And I'm adding owner, we have one, and as we have owner, we can add a new pet. It's obviously going to be Emo. How will you call your Emo, Jeff?
Fred.
Fred. Okay, now we have Jeff owning Emo, name it Fred, and let's say it's a very, very, very young one. So just from November
Yes.
of year 2020. Poor bird. Okay, so now the question is, Alex, why do you show us all those veterinarians and pet types and emus? Answer is very simple. How to set up your application working with Cassandra or Cassandra running in Cassandra? Answer is very easy. Basically, there is a normal Kubernetes way to do the things. Secrets, and that's it. And they're just reusing secrets. So my application has access to the database, which has username and password, and it works seamlessly, and I don't have to do anything. It just works. So the only thing you have to do is to reuse the secret, keeping the username and password. But what happens then if you don't want, if you want to connect manually and you need information about how do you do that? What's the answer? Answer is very simple. If you don't want to use Pet Clinic and you need something different, there are other ways to set up the things. You want to know the password? So do I. So let's take a look at the step 3 of working with data. Step 3 says what we need to switch to console. I will clear it once again. And first, Cassandra stores, as a good polite application, stores everything in kubectl secrets. So, sorry, Kubernetes secrets. kubectl offers a lot of secrets, some of them by Helm, some of them by traffic, and so on and so forth. What's interesting for us now is kubectl get secret. It's named Cassandra superuser. Superuser. Boom. Yep. You see, it's a real live demo. So we have the secret, and now we are going to retrieve some data from it. So I can execute a command like that. kubectl get secret Cassandra super user output with JSON path data usernames, because, well, I need the username here. But it's going to be, okay, I'm hiding the info, but it's going to be something like that. Why? Because those are in base 64 encoded. So full command to expose the username will look like that. And we surprisingly find out what the username of Cassandra super user is. Cassandra super user. Could have been easier, yeah? But we need only not username but also password. So this time I will go with shorter way. kubectl get secret. Which secret? Cassandra super user. Which part of the secret I'm going to retrieve? Data, password. And I'm going to decode it from base 64 and print. And that's my password. That's the password from my Cassandra. Very good. Now, question. What can we do with this tool? Now we know password. By the way, we will use it in the future tasks as well, but what we are going to do with this password? We can use kubectl and CQLSH to jump in and start using things. So, oops, I'm going to connect, and let's take a look at this command. You are going to execute it if you are doing the steps. kubectl exec will execute the command. I will need an interactive terminal. That port I'm going to apply this exec to, Cassandra data center 1 default stateful set 0. So this stateful set 0 is the main Cassandra port I'm working with right now. In this port, I will need to communicate with container Cassandra, because one container may have more than one port may have more than one container, sorry. And then finally, my command will be CQLSH Cassandra super user, and the password is the one I've extracted recently. So I'm putting it right here and boom. Okay, I have a little warning I will ignore for now, but the point is I'm now on the CQLSH terminal for Cassandra, and I can start using that very easy, like, for example, describe key spaces. And we have some key spaces, some system key spaces, Reaper key spaces, and Spring Pet Clinic key spaces. Okay, I can say use Spring Pet Clinic. Done. Now I can show describe tables. We have some tables, and finally I can do some bad things and say like select all, don't do it on your production. For example, for Pet Clinic, select all, from Pet Clinic, pet by owner. Hey, there is the thread emu of Jeff, and it's here. So our application works with Cassandra, our console works with Cassandra, and that's kind of great. So, hey Jeff.
Fred is, I'm just celebrating. Fred is persistent.
Yeah, Fred is persistent. Fred is here. Fred is real.
Yeah.
Hope he will like living with you, and I guess we are proceeding to the next step.
Yeah, why don't you just keep going? We don't have to switch screen back. I think like our next step is scaling our Cassandra cluster up or down, as the case may be. So why don't you keep rolling?
Yeah, I think it really makes sense. So I will switch to the next step then. Okay. And our next step is going to be step 4, scaling up and down. That's a very important thing to be able to scale your database up and scale your database out. So scale your database down. The thing I want to do first is I want to take a look at the manifest, Helm manifest of Cassandra. And if I execute this command, it will look approximately like that. And still listing. That's because Kubernetes, people working with Kubernetes aren't software developers or SRE engineers. They are YAML programmers, basically. They describe all they do with YAML. Kubernetes is an ocean of YAML, and that may be too much for us. So let's focus more on the things we want to have. And what I want to have is I want to understand the current size of my cluster. Of course, I can watch it in Grafana, but we can do something easier. Here I'm going to run the same command, but I'm going to grab size. Current size going to be, well, there are a lot of size things related, but the size what's interesting to me is O. Okay, I guess I'm hiding the values again. Oh my god. Okay, let me hide here on top. Good. So the size, what matters to me now is this size 1. That's exactly the size of the Cassandra cluster with the Cass operator we are having here. And my next thing will be I want to change this site. Now, how do I change this site? Again, in theory, you can try to give the direct commands to Kubernetes, to Helm, to Cassandra, but it's not the best way. The best way is to keep your infrastructure as a code and describe your infrastructure, describe what you want to have in your files, and then apply those files. Then just attach Git, and boom, you have history of all the changes you are doing in the Git, despite you are changing infrastructure. That's incredible improvement.
That's the best way.
That's incredible improvement. It saved my ass in some situations. For last 5 years, I'm actively using infrastructure as a code. But anyway, what the thing we are going to do is we are going to change Cassandra, and that's the Cassandra definitions here. What's important for me? And the important thing to me is the data center size. So in this case, I'm getting down here, switching to a size, and I'm going to raise it to 2. In the documentation, you made the suggestion to raise it to 3 nodes, and it's a great suggestion, but last time I did it, my training node was very busy afterwards because 3 Cassandras running on a single machine. It's a Cassandra it's a Kubernetes in Docker installation, so it's a big machine, but it's already running.
That's a MacBook Pro, right?
That's not a MacBook Pro. I'm running
a
AWS T2 extra large.
Oh, I see. Yeah.
So
okay.
it's maybe not enough for 3. If you like expect with 3 maybe too much, then stick to 2. And I'm saving my changes, and all the things I have to do afterwards is simply, kubectl, sorry, Helm, because we are using Helm manifest here. Upgrade, because, well, I'm upgrading. What I'm going to upgrade? I'm going to upgrade my deployment. Which type of deployment is going to be? Cassandra. You don't have to type it on your own. You have it, describe it, and you can copy paste it from them. Wiki. And which file I'm going to apply is the main one. That's going to be cassandra.yaml. Helm upgrade Cassandra. Good. Applying those changes may take some time. But now we see what the revision 2 is done, and it may take some time to deploy. So let's take a look at the watch. kubectl get pods. So we have 1 stateful set successfully running for half an hour already, and we have 2nd stateful set in the pod initializing state. It may take some time. Obviously, soon we will see those changes in the Grafana as well. So again, It's fully automated. We don't have to add it to the monitoring because together with Grafana operator, with labels, and so on. So there's a lot of work behind that, but we have everything monitored as well. And thing we can do right now is to check manifest for Cassandra, for Cassandra again. And this time we will have size 2 as I set it as a desired size.
Yeah, there you go.
Second node will have, we'll use first node as a seed to join the cluster automatically, and they will work together in a single cluster. Again, I don't have to do it manually because it's done for me. And now, Jeff, do you have an idea how do we scale cluster down?
I would guess that you do the same thing.
Exactly.
Except in reverse.
Yeah, exactly.
Change the number now.
I will simply put the number in the file and apply this file again. As everything is described, I don't have to change anything. It's already working for me, and I guess I'm going to have my node status here very soon. Not yet updated, but going to be there in a moment. But okay, my node was not running, so obviously I don't have it here right now. Node status up, and my node is about to start. Good. So, saving some of our time.
Yeah.
I'm getting back to my file, Cassandra YAML. I'm switching to my data center DC1 and switching size to 1 again. And now I'm going to apply those changes in the way I did it before. So it's always upgrade. That's funny a bit, but if you think it's very similar idea in Cassandra, there are actually technically in the end 2 kind of statements: select or upsert. With the nature of a Cassandra is going to be insert as an update or update as an insert, depending on the primary key. And basically here is the same. We always upgrade. We're adding something, we're removing something, but it's always upgrade for the system. And now we have a revision 3, so we can
that's right.
say helm get manifest Cassandra. We will have again size 1, and obviously we can watch our nodes, pods, and first stateful set still successfully running, and second stateful set is being terminated. Very well. So that's how you scale up and scale down. And I'm going to proceed to step 5.
What is step 5?
Step 5 is a Stargate. I'm not sure if I'm ready to show it. That's something, you know what, maybe we should keep it secret. Okay, Jeff. I guess now it's your turn to show a couple of slides.
Okay.
Do we have for the Stargate, you have something to share? So
yes, I do.
I'm switching off. That's your turn now, and let us know what's with Stargate. It's something new for even the most experienced Cassandra users.
Yes, that's right. So one of the classic problems or tensions that we have seen is developers don't always want to learn a new query language. They don't necessarily want to have to think about what the schema looks like. And we know that data modeling in Cassandra and the design of your schema is very important. It has been, because it really affects your performance. So operators are not necessarily interested in spending a lot of time on query optimization or working with application developers to optimize things. And so what we've seen a number of companies do is actually create their own API layers that abstract access to Cassandra. And after talking with a number of those, we had started a new project called Stargate that it basically provides a pluggable architecture for adding new APIs on top of Cassandra. So we don't have to have this world where developers and DBAs or SREs are kind of have it out for each other. We want to be able to provide this API layer. So the way Stargate works is that you can plug any version of Cassandra in on the back end. So, including open source Cassandra, DataStax versions of Cassandra. Stargate is actually integrated into Astra, our database as a service. And now you can run it as part of your Kubernetes cluster as part of the Cassandra project. So you see currently Stargate has, it provides, for a Cassandra database, it'll provide a REST API or a GraphQL API or a JSON style document API or even straight CQL access. And then we're working on some other things. Like this is a very pluggable architecture, so we're working on some other extensions to that. So why don't you take it back and give us a quick Stargate demo, and then I'll pull things back and wrap it up, I think.
Yep, give me a second. So let me switch to my place. Yep, good. And yep. So Stargate is about APIs, and to use the power of those different APIs, you can use Cassandra, not directly with SQL/SH and data modeling for SQL/SH, for SQL, and so on and so forth. To use the APIs like REST, Graph, and so on, there are some things we have to do first. We have to prepare. And what first thing we have to do, it's a step 5 in the wiki, is we have to create the token, access token for ourselves. And we do it with a simple curl request to the API. In our case, it's going to be like that. Oops, of course. First of all, we have to copy it. We have to put the password. And password, you remember, we prepared it recently, and our password was this one. So, and second variable I have to change here is the address I'm going to use. So again, if you are using your own node, it's going to be your own address. And if you are using the training node, it's going to be something like that. And by the way, something is wrong with my node. It's pretty interesting. I will check it in a moment.
Yeah, I see that node is down.
Yep. So anyway, let me...
Live demo.
Yeah, that's a live demo. That's how it works. Okay, very clear, cannot achieve consistency level 1. So what's going on with my kubectl get pods? It looks like my stateful set is not ready yet. The node is being restarted, so I guess it will take some time for it to start. Yeah. Let me check. So kubectl, if it would be running but not answering, I would check logs. But if I cannot check logs, I have to use describe to get the idea of what's going on. Describe pod, this pod. Okay. I think actually it's
readiness probe failed.
Yeah, I think it's just starting, so hopefully it will be fine after a moment. I want to believe, okay, this one is being terminated. Looks like scaling quad Not successful to me. Maybe that's a resources issue. Because, well, 3 nodes were a bad idea on the same machine sometimes.
Yeah, I think it's working as designed.
Yeah, very possible. So, I think.
Do you want me to do the wrap-up slides, and then we can come back and see if it's
really
back
makes
working?
sense. Maybe you have. Do you have local deployment of a Stargate, or we can switch to wrap up first? Indeed.
Oh, do I?
Yeah. Oh, you know. Okay. Yeah. No. Okay. I guess you don't. Okay. So let's switch to where.
Yeah, I don't think I did it since my last reboot. Sorry.
No. 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 Of course. Okay. That's how live demo works. Now, then I'm switching to your slides. Give me a second. Yeah, you are live, and I will try to recover it so we can proceed.
Okay, sounds good. So I think what we'll do is, in the interest of time and allowing you to go through exercises on your own, I think the running repairs is the piece that we will, of the labs, that will let you to do on your own. You'll get some experience of using the Cassandra Reaper to schedule some repairs on the cluster. And then backup and restore is another piece. Is that still in the exercises? That was a piece that we're working on.
It's not in the exercises yet because it's being developed now and delivered in the next version, I believe. They better ask people from Cassandra team, because I know what it's very, very, very close, and hopefully next time we do this workshop, it will include the backing up and recovers. Well, we are anyway out of time.
We are on the cutting edge here with some of this stuff. This is just-in-time development of the Cassandra project, and just-in-time development of these workshops. So we're definitely we're getting these capabilities out to you as quickly as we can. So just to give you the link again that we showed you before, this is all the exercises that we've been going through today are on the DataStax Devs GitHub under this Cassandra workshop. And then if you go to the wiki, that's the best experience for going through all the exercises. And
hey,
they reach out to you, Alex, for the badging.
Yeah. Okay, 2 points very quickly. I've got my stateful set working back finally. So yes, it was a successful restart. And what I'm going to do, 2 things. First of all, I'm switching back to my screen. And yeah, we have it running back. Then next thing, how to work with Stargate very quickly. I will not show it because we have already no time, but to explain quickly. First, you need to get token. It's very easy. You just execute this command. You are replacing 2 statements: your address with your address, and password with your password. Every password is unique. As I have prepared everything already, I can simply repeat this command. Okay, there, I still cannot contact this one. But okay, that's what you do, and you get output like that: auth token, access token. And then you will need this access token to access data APIs. And there are 3 data APIs: GraphQL, REST API, and what was the third one? Document API, like Shameless one. We cannot show all of them, but because, well, it takes some time. What matters here is Stargate.io. It's a very good place to start if you want to use those APIs and take a look on how it works. Easiest way to work with, oh, where is my postman? Easiest way to work with REST and document API is to use Postman because, well, curl is great, but not the most simple one to use, and you have a lot of things to fix. With Postman, as DataStax prepared the collections, you can simply reuse everything what we created. So in my case, I've imported 2 collections already, Stargate Document API and Stargate REST API, and I can use them defining variables. So if you switch to the beginning, and you, oh yeah, good, you have a, let me make it a bit bigger. Okay, Postman doesn't give me make it bigger. I'm sorry. Zoom a bit more. Okay, doesn't work. Sorry. But what matters? In the core of the collection, you can set up variables. There are 2 variables you have to set up: base URL and authentication token. Those variables will be reused. On the left side, you have the list of the ways you can do using Document API, and the same for REST API. And you can execute those statements, and they will be used automatically in the headers. So base URL is used in the path, and auth token is used in the X Cassandra token header, which you use to attach the token. In my case, it obviously will not work. I have to update the token, but that's not the point. For the GraphQL, when working with these graphic, yeah, in the list of HTTP routers, you may find one called Playground. It's a playground you may use to work with GraphQL. If you are into GraphQL, it may help you a lot. So I'm simply getting the same link I'm using for everything, putting it here and switching from port 9000 to port, oh my god, was it 8000? Correct? Yeah, it's described in the documents anyway. 8080. Good, 8080. And last step will be Playground. This one helps me to work with GraphQL Playground, and therefore use all the GraphQL schema and normal GraphQL IKEA operations. Good. And last point, what we have to mention, like, okay, everything in 1 minute is repair. If we go to repair, and should it be enough? Nope, not found. Okay, web UI correctly. Links are in this wiki. I'm trying to do everything with my own. It's a great tool. It's Cassandra Reaper, which helps you to automate repairs. So in my case, it will not work because it looks like I cannot connect to my node. How? But this one is running, by the way. Interesting. Good. And here I can schedule repair and make it apply it immediately, or apply it on the schedule using the cluster I have. I can specify, or I have to specify, the key space I'm going to use. For example, Spring Pet Clinic key space for my application. Who is the owner? Okay, Alex. When it has to be executed. Interval in days, I want to run it weekly. I'm adding this schedule, and the repair will be executed automatically by Cassandra Reaper. By the way, Jeff, do you remember who developed this Reaper originally? It was...
Originally?
Yeah, originally. It was some familiar names and familiar company.
Oh, yeah.
Okay, I don't remember.
Yeah, I mean, Last Pickle
The
folks,
Last Pickle
John
folks.
Haddad, there's, yeah.
Yeah, so thanks them so much for making this happen. I'm running this repair, and it should come here. And it happens in the running repairs. So for 5 tables, we can view segments. They are not started yet, they are only scheduled. And we have to proceed to the next steps So anyway, you are going to do it on your own before and see some things we are going to do. So let's switch to the slides then, because we have to mention a couple of more things.
Yes, we do.
So
one of the things that I want to emphasize is, this is a project with lots of active development happening. We just released the 1.0 release of Cassandra last week. If you want to be up to date on everything that's happening, a really good thing to do is follow on Twitter right now. We obviously, the core project is on GitHub at Cassandra. And then Cassandra IO, there's a lot going on there. The documentation team is cranking out step-by-step tutorials. We just launched a blog last week. We'd love to get some articles from people in the community that are using it, using Cassandra. We're working on adding forums to the website, so that'll be coming pretty soon. And one of the things that's really cool is if you go to the documentation part of the website, you can actually you can read a page, and as you're working through the instructions on a page about how to do something, you find a bug or an error, you just click on edit this page, and that puts you right into GitHub to do you can do a quick correction and submit a PR. So you can do a correction or a comment, submit a PR, and then you're instantaneously helping with the project documentation, which is pretty fantastic.
yep.
We're also working on certification for, we understand that there's a lot of people that maybe have history as a DBA, like running databases, and they want to upskill and up level to, becoming an SRE. That is, instead of just managing the health of a single database, you want to manage the health of an entire application, full stack, top to bottom. And so this certification is based on running Cassandra and Kubernetes, connecting it with your application, a lot of the things that we've been talking about today that Cassandra does. So if you go to the certifications page at datastax.com, you can actually sign up for the mailing list to get notifications about this program. We've launched a training course, and we have about half of the modules done. We think there's going to be about 9 learning modules for this course, and we've already got 4 of them out there, and more coming every couple of weeks. So we're trying to get this material. This is a fast changing area, just trying to get things out to you as quick as we can. And just to emphasize, we want to be highly interactive, and so please connect with us if you haven't already on whatever your favorite social platform is. And then I've opened up some spots on my calendar, and so is Alex. I'm interested in hearing what your experience is like running Cassandra, like how you think you're intending to use it, or how you think you might use it, or what are you curious about how it works? Did you run into problems getting it running? Do you think the documentation could be better? Any of those things, grab a half an hour on our calendar, and we'd love to sit down and talk with you. We really want to build this community out around running Cassandra on Kubernetes, because we think that it's really the wave of the future. Like, this is the way that moving forward, there's probably going to be more Cassandra running on Kubernetes than anywhere else. I like what you've done there with my talking head, Alex. That's pretty good.
Yeah, I mean, you was hiding your Calendly link, so I have to move it
Oh
somewhere.
yeah, don't hide my Calendly link. It's really simple. And we could put it in the chat there too, or maybe David will help me out, because he's like a mad link pasting guy.
Yeah, exactly. And yeah.
I think that's really it.
Yeah, no,
Do you want to do some questions?
Yeah, take a look. You wasn't doing live workshops for almost 1 year, and you missing
How did
the
I forget the Menti? I know.
No, don't forget Menti. People will
my undying shame.
Remind you anyway. Don't worry, nothing bad happened. We still don't, but I have to say to all the attendees, don't worry, we're still running Menti. That's all. That's it. All good. All good. So for Menti, I'm switching Menti. I'm switching it to my screen and boom, 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 boom. Good. So let's play a game. Top 3 places getting the prizes. And don't forget, jump back. That's menti.com. Use the code 7162049 or scan the QR code next to Jeff and jump in. We can't wait to start because there is a lot of interesting happening and you can win the prizes. So 24 people live. No way, 25. That's not serious. I will not start with such low numbers. Really. I need more thumbs up. Then you jump in, push that thumbs up. I will know what you are in. 30 people. That's already getting somewhere, but no people, no quiz. We did a good job doing that, so now we need you to do the good job and jump in and win some nice swag. We have almost 100 people on YouTube and I need at least 50 before we go on. Or we just close the workshop. No homework, no quiz, no nothing. I hope you are going to change that. Yeah. Okay, 40 people. Few more joins and we will start. Don't forget, now this is a quiz. There is a competition. There are a few dozens of people participating. So what you are going to do is to be very focused. Watch your mobile phone screens, not YouTube, because YouTube has a little delay. And afterwards, you're going to answer very quickly, but give me the correct answers. 5 more seconds. Jump in. 5, 4, 3, 2, 1. And we are starting. Who is late? Is late. So, question 1 of, oh my God, press enter to start countdown. Okay. Answer fast to get more points. What is Cassandra? What is Cassandra? Cassandra with an integrated data lake. MariaDB on Kubernetes deployment tool. Kubernetes native Cassandra with built-in operation tools. The sister of Kate and Sandra. So, okay, most of you have answered it already. And the correct answer is Cassandra is Kubernetes native Cassandra with built-in operations tools. It was easy, but that's just a warm-up. There are some more complicated questions for you then. And I see some answers. Cassandra with an integrated data lake. That's not the correct answer. That's not the correct answer. So, leaderboard. What is the leaderboard? Who was the fastest? Casper was the fastest with Joanna on the 2nd place and Krok on the 3rd. But you know what? In the beginning, they're always like that and difference is so low. So point to point. Let's take a look how it goes after the 2nd question. And 2nd question starts now. Question number 2. Answer fast to get more points. Ingress allows for communication to the internal Kubernetes from the outside network. True or false? Today we are so gentle, Jeff. We give them like some time to warm up, so simple questions. Time is almost over. Last second. Okay, it was again too simple. We need to add more tricky questions, but not in the beginning. So let me see how you did that. Who was the fastest one and who was the slowest? Casper, not Alex, they're penguin. Okay, but are there any changes? Bell was fastest and Bell jumps directly to a 4th place with 1 point difference to the 3rd place.
Oh,
Bell,
that's close.
very well done. 1 point is like, what is it? Is a microsecond? Something like that. So winners, don't relax. That's not yet that finished. Bell, go. That was a good work. And well, I have no idea who is on the second place with 1,917 points. That's not Alex.
But we know who it's not.
It's not. Yeah, it's definitely not Alex. 100%. So, question 3. Answer fast to get more points. What is the Reaper? We didn't spend too much time on it, but...
Don't fear the Reaper.
Yeah, don't fear the Reaper. In Cassandra world, Reaper is your friend. So, is it a backup and restore tool? Is it an anti-entropy tool? Is it a data deletion tool? Or is it a pretty green person? Okay, that was the tricky question most of the people got into. I always have some traps for you. So Reaper is
that was a
not...
definite trap. Wow.
No. Who says what Reaper is a backup and restore tool? I've just shown you. We need Reaper to to keep the data consistent, to get rid of entropy, to keep your data consistent. Reaper is to repair your data and this way counteract entropy, make your data consistent. It's not for backup and restore. If you are looking for backup and restore, you need Medusa, which is already in Cassandra, and we are going to show it very soon. But for now, Reaper, and Reaper is your friend. So I expect a lot of changes this time. But take a look, all of the winners are here. None of the winners made a mistake. And not Alex was the fastest one. That's, you know, it's kind of not really, it feels bad. Not Alex was the fastest one. Okay. So
not Jeff has not even made the leaderboard. I'm not sure what's happening with that.
Yeah, that's weird. Okay, so we have not Alex on the first place, VS on the second place, Janusz on the third one, Penguin get out from the top 3 to the 4th, but still very small difference, and Bell holding the 5th place, getting ready for the attack to the top 3 list. Okay, so we have something happening here. And here comes the next question. Question number 4. Answer fast to get more points. What is the Stargate? Repair tool supporting Reaper, backup and restore tool, data gateway to upgrade your data API, TV series.
Oh.
Not easy, not easy. Time is up. Oh yeah, okay, still easy. People listening to you, Jeff. So, Stargate is the data gateway to use multiple possible APIs like REST, GraphQL, document, and still keep your data in Cassandra, like take care of your data in many ways, but still using all the awesomeness of Cassandra. It's not a repair tool, it's not a backup or restore tool, and well, no one answered it's a TV series. Okay. So, are there any changes on the leaderboard? No mistakes, but a different pace, different reaction time. Penguin was the fastest, getting back to the top 3 directly to the second place with 3,777 points. Well done, Penguin. And you know what? The Penguin has a profile picture of a crocodile. I think someone is having identity crisis, something like that. But I'm not here to judge. Stay strong, dear Penguin. You will be good. We are together with you. And not Alex is holding the first place. Who is that? And Janusz is on the third place. Bell, keep fighting. Like just 4 points difference.
There's rampant speculation as to the identity of not Alex. There's all kinds of rumors. I see it.
Okay, so let's take a look then. What happens next? We are very close to the end of the competition. Question number 5. Answer fast to get more points. What is Helm? a package management tool for Kubernetes, a drop-in replacement for Kubernetes, next generation database, Viking's Head. Yeah, Helm is a new thing even for experienced Cassandra people, Kubernetes people. But the answer is, it was too simple. Was it a Cassandra workshop or Helm workshop? You were supposed to make more mistakes here. Great job, I'm just kidding. So, package management tool for
It just took everyone a while to warm up.
Yeah, well, it's not exactly the package management tool. It's not an apt-get or yum, of course, but it's working in a very similar way. You're adding repository, you deploy the system, describe it in the manifest. And it's not a drop-in replacement for Kubernetes, 100%. So what are the changes on the list of the winners? No mistakes again. VS was a bit too slow this time, I'm sorry. Tech was the fastest one, getting to the 8th place. Great job, Tech.
All right.
But still some fighting happens. And take a look how I would say, top 4 positions are really point to point. Like that's very close. 20 points different, 30 points difference.
But Tej is coming up on the outside.
Yeah.
This is getting tight.
That's a real competition, I could tell you. Okay. So let's take a look what comes next. And that's going to be the 6th question. Answer fast to get more points. Cassandra uses traffic as dependency management tool, Kubernetes ingress, monitoring tool, air control service. Well, it's kinda air control service. It's very close to it, I would say. A lot of similar ideas behind, I would say, but most of you answer it correctly. It's a Kubernetes ingress managing incoming connections to your Kubernetes cluster and dispatching them to the proper services, including Cassandra. It's not a monitoring tool, although it has a very nice monitoring dashboard indeed, but it's not a monitoring tool, and it's not a dependency management tool. So, one question left. There are no mistakes by the leaders again, but some people are getting faster. Janusz was the fastest one, getting to the top place.
Wow.
Great. That was a very quick answer, I can say. Der Penguin gets from the first to the second, but that's still enough, you know. We have no difference in our prizes, so first, second, and third place are getting the same prize. So don't be too sad about that. Second prize out of dozens of people. It's a great result. And Bell finally gets into the top 3. Exactly like...
Yeah.
Well job. Last question.
Don't sleep on Jazzbeer as well.
Yeah. Jazzbeer is very close. And that's again like 35 points difference. So that's enough to make a jump. And... Ravike Run Ready is also very close, but there is a bigger difference to others. Okay, so let the battle commence. Ladies and gentlemen, that's the last question in our quiz. Question number 7. Warm up your fingers. Open up your eyes. Prepare. That's going to be the last one. I would say winner takes it all, but no, first 3 places takes it all. Answer fast to get more points. What's the purpose of Grafana? Cluster management, time series database, data visualization tool. No purpose. Grafana is useless.
Oh, don't answer too quickly.
Yeah, but don't answer too slow as well.
Don't answer too slowly.
Time is up, and the correct answer is Grafana is a data visualization tool. We use Prometheus as a time series database for the metrics, and it's definitely not a cluster management. Grafana is a data visualization tool, a great one actually. I spent a lot of time on Grafana during the last year. So, how do you feel? I think we are done, Jeff. I think, yeah, my wife is waiting for me for a dinner. I think we are done. I'm going to stop the translation. No, we still have something
Oh
to
my
do.
goodness. Yeah, I think we do. Don't tease like that.
Okay, so leaderboard. Leaderboard is no mistakes on winners and a lot of fast answers. And not Alex getting the fastest answer, but still getting on the top place. We congratulate Bell with the third place, Der Penguin with the second place successfully defended.
Wow.
And Janusz got the first place with no mistakes done and very, very, very good speed in the answers. So, Janusz, Der Penguin, Bell, please make the screenshots of your phones or I don't know, maybe you're using laptops, computers, whatever. Send them to jack.fryer@datastax.com and enjoy your well-deserved prizes. For others who didn't make to the top 3 but made in top 10, it's a great achievement. You were competing with dozens of people. It's a big achievement to be in the top 10. And if you are not in top 10, still don't be sad. Today we spent so many time together learning new things. So you learned new skills.
You got the biggest prize
Yeah,
of all.
exactly. Knowledge is priceless, and one thing is more priceless than knowledge is your salary. And you are attending DataStax Developers, you are learning new skills that inevitably affects your salary in the end. So that's the biggest prize, I would say. Okay, so one last question before you quit Menti. Quick survey to help us. How do you like the workshop? Now I'm worried. I know our bosses are watching this stream, so if we get low rate, it's like maybe not too good for us.
Is that true? I hate it when I go someplace and the person behind the counter says to me, "Now you're gonna get a survey. You need to give me a 5 out of 5, or I get fired, or whatever it is, right? Or I don't get my bonus." And I'm like, quit playing with my emotions like that.
Yeah, well, what I really want to say is I want you to be honest, but you spent with us 2.5 hours. I know you liked it. Otherwise, you would be quit already.
The ratings are good,
great.
but if you have written like specific comments are even better.
So that's my next question. Any feedback for this workshop or future topics we should cover maybe? This is my favorite part. People sometimes giving great feedback or great advices. Let me hide us so people will be able to put their, yeah. Great job. Yeah, they like it. I like to see more Reaper next time. Oh, yes, me too. I'm sorry. Very good workshop. Kafka. Sounds interesting. We have something also very interesting talking about Kafka or event streaming. Apache Pulsar. We already did Apache Pulsar workshop and we will do it again. Break in between and lab and hands-on required. Break in between. Well, break in between maybe makes sense because it's 2.5 hours together. So little break makes sense. Great workshop. Thank you. Looking forward to see more on Stargate. Definitely, definitely.
Yeah, more on Stargate. There's a lot to talk about there.
Yeah, indeed. So, you know what? I will keep this window open and I invite you to write some more feedback or in ideas. We will get back to it later. Now I'm switching to another screen I wanted to mention again. Where is it? Yes, this one. So, last points about what do you do now? Homework. As said, theory alone is not enough. What we suggest you to do again, you watched this workshop already, do the practice steps, contact me, link is in the wiki, to get your cloud instance if you cannot do it on your own. If you can do it on your own, great. Then do the steps and submit your homework. How do you submit your homework? Answer is simple. I'm getting to the, where is my, oh my god, there is my link for that. This one. How do you submit your homework? You go to Cassandra workshop and there is an issues part. If you are using GitHub, you must be familiar with that. Then you push the button create new issue and there is a template homework assignment. We prepare it for you. So you push the button get started. Yep. And you just fill it like that. In the topic, you replace the name with your name. You put your LinkedIn profile link. That's important for us, so we will publish your upgrade complete. Attach the homework screenshots below. For the next one, we may decide on some formal requirements, but for now, we just want to see you doing the steps. So if you have it running, if you have your API queries executed, if you have your repairs running, then you are good. You just attach your screenshot here and we will, you push the button submit new issue. So I will do it like that. Alex. Oops. Alex and LinkedIn profile link. Okay, let it be just Alex for now. I am putting my screenshot here, whatever. Good. Replace it, and now I'm submitting these. Boom, done. Whew. And which parts you have to do? If you would do all together, it brings pretty a lot of things to do. So we discussed it with Jeff and we decided what we don't want to make you all the steps, but we want you to choose the most interesting for you. So definitely setting up Cassandra,
Yes.
monitoring Cassandra, it's simple, but working with data if you are a developer, that's very required. Stargate if you are interested into the APIs. Running repairs if you are more into the operations. That's definitely what matters. And get your LinkedIn page, get your well-deserved acknowledgement. And I think that's it for today. Jeff, do you have anything to add?
No, I don't think so. I've already got a couple of time slots booked on my calendar, so that's great.
That's great.
Looking forward to talking more with everyone about this stuff.
Yep, so I think that makes us complete for today. And Menti is done, questions is done. Thank you so much. And that was Jeff Carpenter and Alex Volishnev, DataStax team, developer relations team, helping you to be better engineer and enjoying that a lot. See you next workshop. We always have a lot of events for you.